Okay, so in the previous example, we saw how we could use an integral to talk about the convergence of this series. Well, it turns out that result wasn't just unique for the harmonic series that we looked at, but it turns out that can actually work with many different series. And so the result is this: let f be continuous positive and decreasing. Now, ideally, it would be that for all values, but at least we need it to be doing these things. It needs to be continuous, of course, uh, but it needs to be positive and decreasing most of the time. Now, if early on for a few values, it's like negative and it's not necessarily decreasing. As long as it's doing it beyond a certain point, that's the important idea. Okay? So we say let A sub k be defined to be f of k. All right, so we're defining our sequence in terms of f of k. Okay. Then the integral test says the following: the sum, the infinite series of the AKs, and the integral from 1 to infinity of f of x dx either both converge or they both diverge. So either both the series and the integral converge or both the series and the integral diverge. Because you see, I could go back to this picture here, right? I could go back to this picture here, and I could talk about this rectangle, right? I could actually come over here and do the one rectangle here, then the 1/2 rectangle, then the 1/3, so that all of those things would be below the area of the integral, right? So they would have less area than the integral. There's another way that you could actually approach this. And so you'd have that the area inside the integral is greater than the area inside the series. So by making that adjustment, you could get then, well, if the series diverges, the integral will also diverge. So it's kind of a vice versa thing. It works both ways. Here, because the series was set up to be greater than the integral, if this diverges, then so would the series. But you can actually, again, reverse it. You're looking at these fractional amounts this way, and actually say that this series is less than the integral. So now if the series diverges, the integral would diverge as well. So it works both ways. And that's what this is saying. Now in practice, what we're going to be looking at is we're going to be looking at the integrals, because we know how to work with improper integrals. And we're going to see if the integral diverges or converges, to talk about whether or not the series diverges or converges.